So we have to consider the advantages and disadvantages of each source type. 3 advantages of shot holes arise from the burial of the explosive. First, by originating below near surface, the seismic wave does not suffer the high degree of attenuation caused by that layer. It does so on the return journey, of course, but that's still only half the attenuation that would be felt by a surface source. The second advantage is that, by placing a geophone on the surface next to the shot hole, we can get a direct measure of the travel time in the near surface. This can be very useful for datum corrections in the processing. Finally, buried charges also produce much less coherent noise, especially surface waves, than surface sources.
On the other hand, the burial of the source also may cause a reflection from the surface. When this ghost combines with the initial downgoing pulse, and if the ghost and the downgoing pulse are out of phase, we lose some of our frequency content. Shot hole drilling can also be slow and expensive, enough so that the speed and efficiency of Vibroseis may outweigh its disadvantages. 3 disadvantages are obvious because they are the opposite of what's good about shot holes. To wit, a surface source doubles the attenuation in the near surface. It affords no control of weathering information, and it can produce some serious surface waves.
Fortunately, we've been able to work out a number of ways to overcome these limitations. With Vibroseis, we can pump in more of those frequencies which get lost here, both by varying the sweep variables and by using more vibrators. Using more vibrators also permits us to design source arrays for reduction of the surface waves. We still don't know about the near surface, but maybe we can live with that. If we cannot, then an auxiliary weathering survey may be necessary.
As for its advantages, well, Vibroseis lets us do a lot of things that explosives don't, the most important of which is adjusting the frequency content of the input to the Earth. If we want only frequencies between, say, 10 and 70 Hertz, then that's all we input. And if we want to concentrate on the high end, we can do that, too.